I named the lecture after my book, Breaking Trail, and I wanted to call the book Breaking Trail Mountains and Molecules, because those have been the two themes in my life. But the publisher thought molecules wouldn't sell, so it's Breaking Trail, A Climbing Life. And maybe some of you, is anyone looking at me and thinking, she looks pretty normal for doing all those weird things? How did she ever start? So I asked myself that question and thought I would write a book trying to figure out what led from, I had a very sort of overprotected childhood in Chicago and Iowa, and how that led to the Himalayan summits. And so in the book, and in reality, a lot of it started in my freshman chemistry lab. And that blonde woman, Jane Schell, was my professor. She was 23, had a PhD from MIT, and thought chemistry was the coolest subject on the planet. How many of you agree that chemistry is the coolest subject on the planet? Okay. Well, maybe by the end of this lecture, you'll all agree. So there were 4 girls in my freshman chemistry class. We all got doctorates in chemistry, which says something about how important role models are. And that's my handsome lab partner. And we studied chemistry until late one starry night. And he said, do you want to climb Mount Hood? And he's very handsome, so I said, sure. We started walking at Timberline Lodge on Mount Hood, and I was from Chicago. I'd never done anything like that in my life, and I started gasping. He later said I was gasping so loudly he doubted I would make it out of the parking lot. But he was so handsome, I continued, and I reached the glaciers on Mount Hood. It was the most beautiful place I'd ever been. I fell in love with him and with climbing, and had a brief foray at MIT, which was not such a great place for women in those days, and then went to Berkeley in the 60s, if that's a familiar sight, Sproul Plaza, where the free speech movement started. And I picked a climber for my research advisor. We used to go to Yosemite every weekend climbing, but when we couldn't go to Yosemite, we climbed the buildings. So that's Lewis Hall in the chemistry department at Berkeley. When I passed my qualifying exams, I heard of, let's see if this works as well, if I'm here. Does the mic, am I good here too? Okay, so when I passed my qualifying exams, I heard of an expedition to Denali, or Mount McKinley, which is the highest mountain in North America. And I wrote to go along with the expedition, and the advertisement came, and it said that women could go on the expedition at a reduced price, but only as far as base camp to help with the cooking. So I called the leader and I said, well, I want to climb Denali. I don't just want to go to base camp. And he said, well, women aren't physically strong enough or emotionally stable enough to climb mountains like Denali. And it's hard to believe if people can remember back, but that was like the late 60s. And nobody really knew if women could climb high mountains like Denali. So I thought, well, let's try. And I put together an expedition of 6 women. I was 25, but I was the deputy leader. And I think one of the reasons people weren't sure women could is you can see she's carrying about 60 pounds. And we weren't sure that women could carry 60-pound loads. But we did and got up high on the mountain. And for those of you who wonder about why people climb, this picture might give some insights. So I suffer from a busy mind, like I'm always thinking about, you know, what is it, the rude thing you said to someone yesterday and all the things you have to do tomorrow, and why did that happen? Does anyone have a busy mind? They get busier and busier. And people always say, you should meditate, but when I try to meditate, I fall asleep. So this climber is walking on a narrow ridge, and there's like a 3,000-foot drop-off on either side. So what do you think is happening to her busy mind? Is she thinking about the rude thing she said to someone yesterday? She's thinking about where she put her feet, because if she puts them in the wrong place, that might be it. And so what I find is after climbing, that incredible focus clears my mind. And I, for example, the protein folding breakthroughs that I made a long time ago, the idea came when I was on a glacier, because you have a clear mind after days and days of that kind of focus climbing. So anyway, if anyone wants time off, just say, I need to go to the mountains to get a clear mind. It's a good line, I recommend it. So here on Denali, we got up to our high camp, and this was our leader, Grace Holman, a very experienced Alaskan climber. who had tried Denali twice before and been turned back, and it turns out she wasn't good at altitude. There are people who have an altitude barrier, and hers was about 15,000 feet. We're now camped at 18,000, heading for the summit, and she was really feeling poorly. She was like in her 40s. I was 25, the deputy leader, and I said, well, Grace, if you're feeling poorly, maybe you shouldn't try for the summit today. But she was very determined, and so we all headed up. It was a beautiful day, and here we are on the summit of Denali, which is over 20,000 feet, the highest peak in North America. And it was so early that in the 80s and 90s, I would read about the first all-women's expedition attempting Denali. But we did all reach the summit, but we weren't that happy, because that's Grace, and she's like slumped down in the snow. I wonder if we turned off a couple more lights. Is that possible? Just the front ones? Pictures would get better a little bit. Anyway, she was slumped down in the snow, not eating or drinking, and there were clouds around. It looked like a big Alaskan storm was coming in. And shortly after this picture was taken, Grace collapsed unconscious at about 20,000 feet in this very remote Alaskan summit and so that was the moment I became an expedition leader. Here I was, 20,000 feet, leading 6 people with an unconscious person in a big storm coming in. How does that sound? So I actually begin my book, Breaking Trail, at that moment, because that was a transformational moment for me. So this was a huge challenge. And so as you can see, we put Grace in a sleeping bag, wrapped a rope around her, and there's the summit of Denali. And then that's where she collapsed, and then we hauled and lowered her along this ridge. Spent part of the night here in this bivy site, got her down, and as she got lower, she got stronger, so by the time the storm came in, she was walking. And we got down to our camp at 14,000 feet, and were there for several days digging out our tents. But I had been transformed. I'd gone from being like a 25-year-old chemistry graduate student at Berkeley from Chicago, who had done some climbing, to be feeling like an expedition leader who could do really hard things, because I knew that getting a team up Denali, and even more getting Grace down safely and alive, gave me a real sense of self-confidence. And if any of you do read Breaking Trail, you'll learn I had a very tough childhood that led to my really not having much self-confidence at all. So this totally changed me. And by the time the storm finally ended and we flew out from the mountain, I felt transformed, like I could do more difficult things than I had ever dreamed possible. And I don't know if any of you have had that experience where you have something in your life that seems overwhelmingly difficult, and then you do it, and then suddenly you feel empowered to do a lot more things. And climbing's definitely been that way for me. So my life was changed again when a dear friend died climbing. And he was an early environmentalist, and I felt like I wanted to do something to help the environment. I was doing protein folding, which seemed very theoretical and far away from real things. Since it turns out it's really important in cancer and all kinds of health issues, but at the time it seemed pretty theoretical. So I heard about a problem with children's sleepwear. So in those days, all the children's sleepwear in the United States from 75 to 77 was treated with a chemical called brominated tris. You don't have to worry about it, big name. And like 5% of the weight of the fabric was this chemical. So there was a lot, or up to 10%. And it wasn't attached to the fabric, it was just padded on. And when children wore the pajamas with the flame retardant, you could find breakdown products in their urine, like the next morning. And so we looked at the chemical and discovered it was a mutagen, it changed DNA, it looked like it would cause cancer. And I started writing a paper about it. I was really worried because we didn't want all the kids in the country wearing that sleepwear. And then I got invited to this mountain. Does anyone know what mountain this is? Anybody want to guess? A hard invitation to turn down? What mountain would that be? Mount Everest, exactly. And at that point, no American woman had ever even tried Everest. Everest had only been climbed once by Americans in '63. Now Everest is climbed every year, but Americans first climbed it in '63. This was '76, the bicentennial year, and it was the second time Americans were trying Everest. So what do you think I did? I had to choose between climbing Mount Everest and doing something about the chemicals in kids' sleepwear. What would you do? So how many would climb Everest? How many would do something about the kids' sleepwear? Okay, so I did both. And so while I was climbing on the Khumbu Icefall and these incredibly beautiful places on Mount Everest, I was writing my paper for Science magazine. And we had mail runners going back and forth between Berkeley and our different camps on the mountain. This was my high point at 24,500 feet. And there's my flag, the mutants, because tris was a mutagen. So that's the Petri dish with the tris and the Petri dish without the tris. And so I didn't get to the top, but the summit was reached in October. And the next year, a few months later, in January, our paper came out, Flame Retardance as Possible Cancer Hazards. The main flame retardant in children's pajamas is a mutagen and should not be used. And that was pretty unusual in those days, and even today, scientists making such a strong suggestion about a consumer product. And it begins, it's so interesting, with something, this is from over 30 years ago. It begins by saying thousands of chemicals to which humans have been exposed have been introduced into the environment without adequate testing. Chemical flame retardants provide a good example of an innovation where adverse environmental effects may outweigh some of the benefits. So do you think that's true today? Except it's tens of thousands of chemicals now. So we wrote this paper January 1977, and April 1977, tris was banned by the Consumer Product Safety Commission from children's sleepwear. Yay? Right. So some of you who were kids between 75 and 77, anybody, see, you only wore the tris sleepwear for a couple of years, not that long. So when brominated tris got banned, what do you think it was replaced with? Any chemist want to guess? Banned brominated tris, replaced with? Chlorinated tris. Asbestos, that's a good guess too. But it was chlorinated tris. And so we wrote another paper in Science saying that was a mutagen, that got banned. And then I organized an expedition to this mountain. This is Annapurna 1, and it's the 10th highest mountain in the world. When I organized the expedition, all the world's high mountains, mountains over 8,000 meters, had been climbed by men, but not a single woman had climbed that high. And once again, people didn't believe that women could climb to 8,000 meters. But after Denali, I figured women could. They just needed a chance. And we wanted to pick a safe 8,000 meter peak. Annapurna was the first one ever climbed, so we sort of thought, oh, it must be safe. So guess which is the most dangerous 8,000 meter peak? Highest fatality rate, probably the most difficult, Annapurna. So our team at the time ranged in age from 20 to 50, and we're all still friends. It's hard to believe, but we had our 30th anniversary a few months ago, and we all got together, and nobody had changed at all. We needed to raise $80,000 to fund the expedition, and we raised it selling these T-shirts with the famous slogan, and they're still available. And in fact, there are a couple of T-shirts. So if anyone's interested, I didn't bring a whole lot of T-shirts and books, but I did bring some samples, and there's some order blanks. So if anybody wants to order one of our books or T-shirts, come up afterwards, and you can have your own Annapurna T-shirt. So we hiked into Annapurna in the Himalayas, and a very beautiful place. And I started learning leadership lessons. Like climbing a mountain, you have to do lots of things besides climb, like coil ropes and take care of gear. And after a hard day's climbing, I'd see, this is like 19,000 feet, but it was hot with the sun beating down, and everybody's relaxing, and I'd come around and give everyone lots of chores to do. You know how popular that was? So it turned out it was better just to start doing the chores, and then people would join in. So we had lots of problems, huge snowstorms, and then a critical moment for me as leader came when we were going to climb some of the steepest slopes, this sort of ice face, and we'd been alternating leading and following, and I thought it would be safest if the 4 best climbers led. So instead of having a discussion, I just told everyone, these 4 climbers are going to lead. Well, do you think people were happy? Everybody was unhappy, and so we decided to take time off from our climb, talk it out, and the whole group discussed it, and you know what they decided? The 4 best ice climbers would lead, but it came from the whole group. And I learned that when something was happening that was really critical, it was really important to get everybody's input before making a major decision. So here we raised flags to the mountain gods and headed up the mountain. And this is now some climbers heading up to the high camp, and there I am. I'm last. Why do you think I'm last? Well, maybe it's a little bit because I'm a slow hiker, but more it's because I believe in what's called servant leadership. My job as a leader was to make sure the team had all the resources and everything necessary. So I would be giving out the loads, making sure everyone was okay, and when everyone was okay, then I would head up the mountain last. So my job was to make sure things worked, not always to go first. So Annapurna was an incredibly beautiful place, but it was very steep and incredibly dangerous. The reason Annapurna has the highest fatality rate is these huge avalanches sweep down. This cloud grew to be almost a mile wide and nearly wiped out our film crew, picked them up and hurled them through the air, but they were basically okay. And then we headed up to our high camp. Does this look like a high altitude meditation location? Is anybody worrying about the rent when you're walking there? So just when things were cold and we were feeling isolated and discouraged, these flocks of Tibetan geese started migrating over the summit from Annapurna, summit of Annapurna from China to India, honking. You know how geese fly around, and they raised our spirits. And so the geese were our inspiration. And so we headed up the higher slope, some of the most beautiful places I've ever been. Though people ask me if I still climb, and my answer is I quit doing this kind of climbing when I became a mom, because that does not look like a good place for a mom. And so we did reach the summit. This was the first time any American or any woman climbed Annapurna, and we unfurled here a Nepali flag, a woman's place is on top flag, held together by a Save the Whales pin. And so we had made the first, we were very happy. The word went out on the mountain, the summit had been reached. But 2 of our members wanted to make a second summit bid, and they fell to their deaths. So I wrote an article for National Geographic. It was called Triumph and Tragedy on Annapurna, because even though we had climbed the mountain, we'd lost 2 of our friends, and I had really decided that Himalayan mountain climbing was too dangerous. But I had always wanted to walk the length of the Himalaya range, and I met Indira Gandhi. I had done some climbing with Indian women and met Indira Gandhi. And the Indian Himalayan regions are closed to foreigners for political reasons. And I told her I'd always dreamed of walking across the Himalayas, and she said she thought she could help. And so with her help, we got permission to walk all the way across Bhutan, Nepal, and the Indian Himalayas, which was about a year-long walk of about 2,000 miles. And I will not have time to tell the story. Just show, I did the walk with Hugh Swift, who had just written a guidebook to the Himalayas, and he knew which way to go. Actually, Lisa and I, should we say, yesterday we wanted to hike around, what was it, Beaver Pond? Beaver Lake. It took us a while to find it. So I don't have a great sense of direction, but we did find it. And so Hugh knew how to, he just finished writing a trekker's guide to the Himalayan Karakoram, so he knew how to find the way. I knew how to do the politics and get the permits, and so we had this amazing year. And along the way, we took wonderful pictures of women in the Himalayas, and again, I won't have time. And out of that came the Berkeley Himalayan Fair, a big Himalayan festival we have every year in Berkeley, with the proceeds going to Himalayan charities. And I go back now and do leadership training in the Himalayas from time to time. So my most recent and favorite adventures have been with my daughter, Annalise. And when she was a baby, I thought maybe she wouldn't like walking. So we dreamed up for the summer when she was 3 to 6 months old, we would carry her across the Alps with baby. And so we carried her from Yugoslavia to France, going from hut to hut. She's there in her cute little Gore-Tex baby suit. And so turns out she's smiling then. She actually doesn't like walking very well even today. But just include, so Annalise, meanwhile, this was 22 years ago. Annalise is now a senior in college. But I'll put a little pitch in. Annalise, between high school and college, did a wonderful gap year and made a website. Annalise's it's freewebs.com gap year site, where she talked about taking a year off and doing a low-cost gap year, which she was in a very academic high school where the kids were under a lot of pressure. And so she spent a year volunteering. In the winter, in the fall rather, she volunteered in Thailand in 3 Muslim villages that had been, this was just after the tsunami, that had been wiped out by the tsunami, and helped teach English. And then she taught English in Guatemala in the winter. And then in the spring, she, because she has a British passport, her dad's British, got to go to Cuba and made a documentary about the 1962 literacy campaign in Cuba. So she had this wonderful gap year and then came back to college and did really well her freshman year, which she attributed in large part to having that nice year off. And it really, she's ended up in environmental engineering, which I think is great, and probably, I think she would have been in high fashion design or something otherwise. So I think her gap year made her really appreciate the world and make some good choices about her life. So meanwhile, I wrote a couple books, Annapurna, A Woman's Place, which talked about our Annapurna expedition. And then I spent her whole childhood writing Breaking Trail, which was trying to understand my own childhood, which was pretty challenging, and how that contributed to my climbing and my science. So in 3.5 years ago, I finished Breaking Trail just as she was starting college. My mom I'd been taking care of had died. I'd been doing corporate leadership training to support myself, but at that point, most corporations no longer, they used to do 3-day offsites to learn about leadership, and at that point, they wanted kind of the hour leadership course. Nobody took 3 days off to really learn about leadership. So I really didn't know what I was going to do next, and I had quit doing chemistry back when I walked across the Himalayas. I had a choice between walking across the Himalayas and a job at Berkeley, and I walked across the Himalayas. So I hadn't done chemistry since the 80s, and it was 2006, and I was like, oh my gosh, what am I going to do next? And so that is what's been really my life's favorite adventure, which I'll tell you about next. And so it's about fire retardant chemicals, and it's an example of the need for chemical regulation reform, and I founded the Green Science Policy Institute. So the problem in America that most people don't recognize is that chemicals are really not effectively regulated. So in America, foods, drugs, and pesticides are regulated. And the only law that regulates other chemicals before they're out in the world is called TSCA, the Toxic Substances Control Act of 1976. There is a Clean Air Act, a Clean Water Act, but by the time that's happening, things are out in the air and the water, and you really can't bring them back. So when TSCA was passed, 62,000 chemicals were grandfathered, like they're okay, and EPA has only restricted 5 of these 62,000. The 5th was asbestos, and it was overturned in a lawsuit. And then the EPA hasn't really tried to regulate anything since. Anybody surprised that asbestos is not illegal in America? And for new chemicals, there are 20,000 new chemicals. 85% have no health data, 67% no data at all. So when there's a new chemical, the company is required to show EPA the information if they have information, but if they don't, they're not required to show them anything. So that's an incentive almost not to have information. Then EPA has 6 weeks to show a cause for harm, often with no information. And at that point, the chemical is grandfathered. So what this effectively means is foods, drugs, and pesticides have regulation, but chemicals in cosmetics, personal care products, cleaning products, stain repellents, fire retardants, all these kinds of chemicals that can end up in our bodies just as though they were foods, there's no health requirements whatsoever. And I have come to believe that the chemicals are really contributing to a lot of the health problems that are growing in our society. So what's happening with fire retardants? The use of fire retardant chemicals in furniture and baby products is caused by a California law. Like, you all think of California as being the most progressive place, and it takes the lead for climate change, but it's also the place that took the lead for requiring fire retardants. And the standard, that law, is met with halogenated fire retardants. If you're a chemist, that means carbon bonded to bromine or chlorine. They're the kind of molecules that are persistent, last a long time. And some manufacturers comply with this law nationwide. So if you're going to buy a baby product or furniture, you might want to look and see if it meets California's Technical Bulletin TB 117. And you'll find a lot of stuff here in Virginia probably does. This law requires the foam in furniture to resist 12-second flame, but there's no standard for fabric. So if you think of what happens if you drop fire on this chair, what's going to burn first? Fabric. And the fabric can burn, and then the foam only needs to resist a flame for 12 seconds. So the standard actually has not been shown to do much good. But to meet it, the foam is like up to 10% by weight a chemical that comes out and ends up in people, just like the pajamas. And what are the chemicals? Well, for chemists, this is the flame retardant that was used almost exclusively from about 1975 to 2005. And it's 2 rings with an ether bond. This molecule is called a PCB or PBB, 2 rings with a covalent bond. This is a persistent carcinogenic, not great molecule. So there's one atom different. And if you burn or oxidize, add oxygen or complete this bond, you end up with dioxins and furans, which are among the most toxic molecules known. So the fire retardants in our furniture and baby products are halfway in structure between 2 very, very toxic sorts of molecules. So do you think this is a good thing to have in your home, in your baby products, in your baby? So this chemical was banned, and in fact, if any of you ever heard of the Dirty Dozen, banned by the Stockholm Convention, it has now been added to that list. So this is one of the most toxic chemicals around. And again, the flame retardants, they don't stop fires. They just slow them for maybe 12 seconds and end up producing, if they burn, very, very toxic chemicals. So it's maybe not such a good deal. And how are people exposed? The chemicals come out of the products into house dust. And toddlers have 3 times the levels of their mothers in their bodies because these chemicals are fat-loving, so they're in breast milk. They go through the placenta, and then they're in dust. So toddlers who put their hands in their mouths get the chemicals. Californians have the highest levels in house dust and body fluids. This is levels of toxic flame retardant in the EU, in some states, and California. So the potential negative health effects, these chemicals are persistent. That means they stay around for decades, some of them. They accumulate up the food chain, and they cause reproductive, neurological, thyroid hormone, endocrine disorders, and cancer. This isn't mostly animal studies. Babies are born with the chemicals in their bodies, and children today have higher risks of conditions connected to chemical exposures in animals. Attention deficit disorder, cancer, diabetes, obesity, all of these are found in animal studies to be contributed by these chemicals, and they're starting to see some human health effects. These are some, and they're kind of more subtle hormonal effects. Anyway, so do we want our babies with having these chemicals? Probably not. So now the other sort of creature who has very high levels are cats, because cats lick their fur and cats are in the dust. So cats have 100 times higher level than people. And that's my cat Midnight, who when I started this work went from being like a 15-pound cat to a 5-pound cat. And the vet diagnosed hyperthyroid disease. Does anybody here have a cat with hyperthyroid disease? Not so much in Virginia. In California, there's really a lot of it. And people believe it could be caused by these fire retardants because their structure looks a lot like thyroxine or thyroid hormone. So we got a study in Illinois where they measured the level in Midnight's blood and the measure in my house dust. And my house dust was like some of the highest level they'd ever seen, but that's because I live in California. And so I was in denial about this, and I got what's called an X-ray fluorescence analyzer. And I measured my furniture, which was kind of yellowing from age, a little crumbly, from the 80s. And the zipper was right up against the foam, and discovered that my furniture was 5% by weight bromine, which meant it was about 7% flame retardant. And I had the misfortune that all the furniture in my house was pretty much like that. And this picture, actually, if anyone's interested, I wrote a piece for Science, which is up here on the front table, if anybody wants it, and it has that picture on it of measuring the levels. So what happened to my couch? That's my couch. But you notice there are no cushions. The cushions are in my garage, and I actually have about 30 pounds of penta toxic cushions in my garage that are being used for a number of science experiments because the furniture industry actually paid to do the $1,000 analysis on my couch because they were in denial. But it turned out what was in my couch was what was in my cat, which was what was in my dust. Same thing. But do you think sending the couch to a landfill solves the problem? What do you think happens to the chemicals in the landfill? They come out. And so NOAA has a mussel watch where they look at sediment and bivalves all around the coast. And this is the flame retardant penta, the same stuff that was in my couch. And every place where there's habitation, there are these chemicals. And they're all over. And marine mammals have the highest levels. And it's not a joke. Do you want fireproof harbor seals? But people who study marine mammals say, because the marine food chain is so complex, if it's in sediments and it's in bivalves, it keeps increasing. And by the time it hits marine mammals, they have high levels, and they've been having recurring disease and mass mortalities. And these marine mammals are like washed ashore with these sky-high levels of these chemicals in their bodies. So it's really a problem, and it's all kinds of creatures. So this penta was 98% of the usage was in North America to meet the California furniture standard, but it's in polar bears, killer whales. If any of you saw on Earth Day, Cousteau had a special on killer whales. Did anyone see that? Because anyway, he found really high levels in killer whales, and then he and his staff measured. And his chief scientist and her 4-year-old son got measured, if you remember, and her 4-year-old son had a really high level. And so they found me and now made a partnership to work with us to help stop the use of these chemicals. But anyway, they're in all the top of the food chain creatures. And when you ban one of these chemicals, like this Deca, which is very similar, 10 bromines with the oxygen bond, with huge amounts of lots of states, I think not Virginia, but it's been banned in Washington, Oregon, Vermont. State by state, there are these huge battles. They ban Deca, and then the deca-bromodiphenyl ether, and then the replacement is the deca-bromodiphenyl ethane, which still has 10 bromines and still is accumulating. Here it is in panda bears in China, all over the world. So this is a real problem. And so what should we do about these chemical issues? And I should just say that this might, I'm not sure, people are thinking, oh, this is just boring chemistry, but this has actually been, to me, more challenging and more rewarding than climbing Annapurna, and it's really been like an expedition, getting a team of people from all over the world together to solve this problem and protect human health. And in the last 3 years I've been doing it. Has really been like the most amazing expedition of my life. And we've concluded that you want to use fire retardant chemicals only when there's a need, and you can't do other things. And you want to move away from the toxic chemicals to safer alternatives. So you can have fire safety without toxic chemicals. For example, preventing ignition is less expensive and more effective than adding chemicals to slow ignition. So the idea about flame retardants was heavily promoted by the tobacco industry. In fact, it's tobacco industry people who are leading the campaigns for fire retardants, because they came up with the idea of shifting the blame for fires from cigarettes, which do cause fires, to consumer products without flame retardants. So their motto is that everything in our homes should have flame retardants in it. But instead, you can have fire-safe cigarettes and fire-safe candles. And in Virginia, you have now passed a regulation, you don't know this, for fire-safe cigarettes. So what's a fire-safe cigarette? So most fire deaths happen when somebody's smoking, they fall asleep, the cigarette smolders for 20 or 30 minutes, the couch, the bed bursts into flames. A fire-safe cigarette is, here's a fire-safe cigarette, this pink strip, the paper's twice as thick. You drop your cigarette, it comes to the pink strip, there's no oxygen, it goes out. Simple, low tech, no more, way less fire deaths. And then you go further, there's another pink strip. And it's actually, I called for those 30 years ago when I wrote my science paper. It's taken 30 years because the tobacco industry was so opposed to it. But after 30 years, we now have Firesafe cigarettes. We also have Firesafe candles, which is the other major source of fires. So fires are really going down. And does the California standard work? And as I told you, if any of you are going to have babies, look and see if your baby products say TB117 and contain foam, because that means they've got these fire retardants in them. So California is the state that has had this in their furniture since 1975. And other states really don't use it in furniture very much at all. And if you look at the change in fire death rate of California compared to other states since 1980, when we have data, does California look like it's doing any differently? California has less fire deaths because there aren't as many space heaters. You know, we have a different climate. We have fewer smokers. The main thing that correlates with fire deaths is smoking. And in fact, I think in the last slide I said the things, wrong direction. The things that make a difference for fire deaths is a decrease in cigarette consumption, enforcement of building codes, sprinklers, smoke detectors, fire-safe cigarettes, candles. All those things make a difference in fires. Putting chemicals in consumer products might make a difference, but it's not big enough to measure. It's a very small difference. On the other hand, when Firesafe cigarettes finally passed in 2007, Reynolds American said they were going to do it all over. The National Fire Protection Association estimated 750 lives per year could have been saved if we'd had Firesafe cigarettes 20 years ago. So that's a huge number of deaths, injuries, fire losses, all stopped by this simple expedient of making the paper twice as thick on your cigarettes. And when you ask the National Fire Protection Association about adding chemicals, they just said the fire data isn't detailed or complete enough to show whether adding chemicals to furniture in California since 1980s made a measurable difference. So you can see that there are lots of better things you can do than put chemicals in everything in your household. However, there is a strong incentive for putting chemicals in, and the chemical industry pushes for it very, very strongly. So now I'm going to tell you about the hardest thing I've ever done. Harder than climbing Annapurna? Does that sound possible? A chemical thing that's harder and I think more important? So 2 years ago Thanksgiving, I heard about this international electronic standard. It's a worldwide standard for electronics. It says the plastic enclosure around consumer electronics, that's the plastic that goes around computers, printers, faxes, all electronics, would have to resist a candle flame. Now, the electronics is all protected against fires inside, against sparks and heat. This is only about the plastic enclosure resisting a candle flame. So how many candle fires do you think there are in computers in the US in a year? None. None recorded, no deaths. Nonetheless, the chemical industry came up with this idea in 2002. And there's this international standards body in 30 countries with 30 committees all over the world doing secret votes. And this standard had been making its way through all those committees since 2002. This was 2008. The final vote had already started. And I was told it was going to pass. And I was also told that 1.7 billion pounds of fire retardant chemicals would be required to meet that standard. Now the penta that causing all the problems in all the wild animals and my cat, only 20 million pounds a year was ever made of it. And so do we want 1.7 billion pounds of fire retardants? They wouldn't all be bad like penta, but some of them might be, to deal with candle fires. No. But why, and the companies, it's actually interesting, companies like HP, Dell, they were all going along with it, even though Dell said it was going to cost them $80 million a year just to buy the chemicals for all their electronic products. And the reason they were going along with it was the marketing of the chemical industry was to go to these companies, and this is apparently legal, and say, if you don't put these chemicals in your electronics, we think you don't care about fire safety, we're going to run TV ads showing your HP or Dell, whatever, IBM computer burning and saying that your products aren't safe. And that's apparently legal marketing. And so they did, and you know what the companies all said? Oh my God, we'd lose our brand. We don't want that to happen. So the companies all said, okay, we'll have the standard. We're not going to vote against it. So I heard about it, as I said, not the best Thanksgiving of my life. And so I looked on the NGOs. These are the environmental groups, non-governmental organizations like Sierra Club, Friends of the Earth. And I said, what's happening? And they just said, it's been going on since 2002. It's isolated, secret votes in 30 countries. The NGO community can't do anything. So then I went and talked to Underwriters Laboratory because they vote on the standard. And they said the standard was being voted on from December 2007 to April 2008. And they said the standard's being voted on right now. You can see them after they pass. They're a secret. You don't even know what the standard is. And there's no way you can have any influence. If you want, you can pay a bunch of money and join the American committee, but there are 30 committees. So does that sound more challenging than Annapurna? And I said, over my dead body, are we going to have 1.7 billion pounds of fire retardants in all the electronics in the world? The problem is they come out, the health problem. Also, when you add the chemicals to the plastic, you can no longer recycle the electronics. So like HP said, we can just keep recycling plastic. It's cheaper to use recycled plastic than new plastic. But when you add the flame retardants, all you can do is burn it. And remember, when you burn those chemicals, you get dioxins. So it was really a bad deal. So what do you think we did? We wrote a scientific paper, The Case Against Candle-Resistant Electronics. And we got 100 NGOs from all over the world somehow to sign our paper with logos. And we got from universities, Carnegie Mellon, Green Chemistry, there we are. Carnegie Mellon Institute for Green Oxidative Chemistry. Anyway, this was just some. We ran out of space, Swedish Society for Natural Conservation, Sierra Club. We got all these groups to endorse this paper, and all in the 30 countries, we got people in those countries trying to give it to the voting committees. And we got people like firefighters on our side because firefighters have very high levels of 4 kinds of cancer that are connected with exposure to dioxins. And the firefighters knew that the chemicals didn't do much for fire, but they had to clean up after the fires and had higher cancer incidences. So it was like a miracle, but we actually were able to defeat that standard. And if you want, what happened is I wrote this big paper. We tried to get it out to all these committees. Then we started getting terrible letters from the chemical industry. Miss Blum is a Berkeley consumer activist who's opposed to fire safety, that kind of thing. But when they wrote the letter, that letter, instead, the chemical industry knew all the people on all 30 committees in all 30 countries, and they wrote the letter to all those people, and instead of BCCing, they CC'd everybody on all 30 committees. So you know what we did? So here we had some, electrical engineer in Bulgaria who'd never heard from anyone before, who's getting letters from firefighters and scientists and environmental organizations. All saying that, if this standard passes, it's going to be a catastrophe for the planet. And so by the time the vote came, we needed 25% of the countries to vote no, and 58% voted no. So it was amazing. So this was a cover story on Conformity, one of the electronics industry magazines describing the whole thing. So doesn't that sound harder than climbing Annapurna? and if I hadn't climbed Annapurna or done all these expeditions, when everybody in the world said this is absolutely impossible, it did sound pretty impossible, didn't it? Secret votes in 30 countries where you don't know anybody. I don't think I would have tried. But I think Denali started it. So I think the skills from mountain climbing can lead, to when you succeed at something really hard, then you can do other really hard things. So we actually, that's my most dramatic example, we were successful in 10 different chemical industry initiatives stopping added chemicals. And then when we weren't so successful was in California, where we wanted to stop the requirement for chemicals in furniture and baby products. And so we had a bill originally to stop the requirement in furniture that would have maintained fire safety without toxic chemicals. And then that actually failed after the chemical industry spent $10 million in advertising and other things. And then right now, we just had a bill on baby products. So some of you may have heard of Heather Stapleton is an analytic chemist at Duke, and she's the best person in the world for measuring these chemicals, and she had a baby last April, and that's Heather's Graco stroller. So she measured it, and it was 3% chlorinated tris in the foam. And then like this is a breastfed nursing pillow, and my friend who had it called the company, and they said, well, don't worry, it's not a PBDE. And I said, well, yeah, it isn't, because they've all been banned, but they said it's, anyway, this chemical, which is another chlorinated phosphate that's 37% chlorine, that we really don't know anything about. But you know, the chemicals are volatile, they come out, they end up in the baby. So I mean, do we want this in our nursing pillow? And there's no fire hazard for these baby products, according to the Consumer Product Safety Commission. So we had a bill, SB 772, to exempt the foam in nursing pillows, high chairs, cribs, and strollers from this requirement. And because the same baby products are used across the country, unfortunately, the baby products that you buy, if they contain foam and they say they meet TB 117, they are very likely to contain these chemicals. Anyway, we did not succeed. The chemical industry spent a huge amount of money, and our bill has become a 2-year bill, but it's very tough. And this is the sort of advertising. And when everybody in California got like a mailer, 2 mailers, if you think of what that costs, paid for by Californians for Fire Safety. And who are Californians for Fire Safety? They're the 3 companies that make the fire retardant chemicals. And to give you an idea of what they spend, this was a budget for 1 quarter with one of their lobbying firms, $6 million, but they have lots of lobbying firms. So it's been a little bit of an unequal challenge. We've actually not really had funding the whole time we've been doing this. I've been a volunteer, and I've had lots of other volunteers, and then I actually got this $100,000 prize, which was really nice, the Purpose Prize, which for our 3 years' work. But so we are right now hoping that we can make our organization work a little better and get postdocs and more students, and really be successful at helping protect our population and indeed the world from these toxic fire retardants. So if anybody wants more information, please leave your card or sign our list. I have sign-up sheets. I send out newsletters. There's 2 varieties. One is 6 times a year about chemicals and treks in the Himalayas and lots of different things if you want to sign up for our newsletters, or I also send out ones maybe every week or 2 with information about reducing toxics and toxic chemicals. And in fact, we have a sheet over there on how to reduce the toxic chemicals in your home, talking about how to reduce your family's exposure to some of these untested chemicals. Because so far our government, they're trying now, the EPA is trying to actually start enforcing regulations and protecting us, but it's going to be a struggle. So if you want more information, that's my mountain climbing website, and that's Green Science Policy, our website. And both of these, I think, are different sorts of adventures. And so maybe I'll leave you with one of my favorite images. Mountain climbers like the idea of walking across the clouds and then climbing to the summits of their dreams. My dream is a world without toxic chemicals and with greater health, but you can all imagine reaching the summit of your own dreams. Thank you.